Okay, so good to have all three of you join in for the core module. We have covered the introductory module, and we've covered some of the essentials of the field of apologetics, the goal, the desire behind why we do what we do. And so now we'll be getting into the crux. And anyway, the all three of you are very familiar with what I'm going to address, even the entire core module structure, or even what we're going to discuss right now in this session. So um, I may so I may breeze through a bit if no one else joins in, so that we can get to some doubt clearing or some Q&A part that we may have, and just tease our brain, do some brainstorming with this topic and as such, or that we can also share some interesting points that you may have also learned in the process of reading about the Kalam cosmological argument and as such. But before we do that, I just want to tell about our certification process. So we have the official backing from Reasonable Faith to provide official certificates on behalf of the Reasonable Faith Bangalore chapter. And so the intent is that you're all going to you're all pouring in about 16 to 17 hours, 16 hours of your time into this modules. So we wanted to appreciate and recognize that. And since it is coming from Reasonable Faith, there is the uh, I'm not going to say that it has some sort of degree level or even in official certificate level validity that it may have with certificate courses in the US universities, but it is something that you can keep for yourself. And if you were to show it at any other Reasonable Faith event or any other chapters that you may be connected with the rest in down your life, down the path at any part of the world, that'll be beneficial. So we just wanted to provide you and acknowledge your contribution and effort this into this modules. So here's how we're going to make sure whom to give and whom not to give. There will be session outlines that are going to be uploaded for. We have been doing that for all the sessions that I've been taking, and we'll upload session outlines for all the core module sessions as well. And these are very simple, direct uh, questions to fill up, maybe two or three fill in the blanks as such, just to know, just for me to have some way to evaluate whether you have been listening in or not. So all you have to do is fill up those session outlines, type it up or write it down with a pen, pencil, and just hand it over to me. And if you are able to, and if you're able to express and display um, apt answers to it, then it can be taken as a way of acknowledging that you have listened in and have understood the topic that are being taken here. So even if you jot down some quick points of what is happening in the PPTs, it'll be more than enough content for you to answer on the outlines. So that's just about it. And I would prefer that if you're interested with it, just let me know. And all you have to do is just submit the session outline, the filled up session outlines before the more next hour happens. So you have 2 weeks of time to fill it up and submit to me. So the person who submits all of these session outlines in time, aptly writing it for the core module, will be provided with the certificate from Reasonable Faith Bangalore. So this will also be signed by the global chapter director as well. So there's going to be, it's not just going to be my signature, it's going to be Tyson's signature as well. So we're looking at that to get that sorted. So that's all set and done. Everything is cleared up from Reasonable Faith's end, and that'll be the way we will be proceeding with it. So that being said, Stephen, if you can just start screen sharing, we will get into the topic now. So we're going to look at the Kalam cosmological argument. So in the next slide, we'll see what are the 3 points that we are going to cover. So we will briefly touch through what the KCA is. Again, like I said, this is something that will be very familiar to all three of you, especially to Stephen, because we just did a recording for our podcast. We are resuming our podcast with season 4. And so we are getting into the core of natural theology, into the arguments for God's existence. And we were talking about the Kalam and as such. So for Stephen, this is going to be a refreshing course. For Jacob Chan also, I know this is nothing new to him. And for Shubhraji, again, same story. And then we will look at premise 1, and we will look at yeah, Shubhraji, you're unmute. Okay, and then we will look at the scientific arguments for premise 2. So quickly touching on what is the KCA, focusing into that, what we see is that the Kalam cosmological argument is actually part of the whole cosmological argument family. So you have the cosmological argument by Aquinas and then Leibniz, and then there is the argument that we are familiar with. So, and as we know, this has to do with because these arguments focus about the universe as a whole. I was mentioning it in the podcast with Steven that even the argument, like the fine tuning argument is about how the universe in and of itself is fine tuned, but we don't call that as part of the cosmological argument family, even though it is talking about the cosmos in and of itself. It's interesting to look at Aquinas' cosmological argument and Leibnizian cosmological argument. Some people get them confused, um, because there is a fine line differentiating Aquinas and Leibniz because of their phrasing of the argument, what is at the core of those arguments. But there is a distinction as to what they are both trying to show and how they're trying to show. Now, the KCA was originally presented and was conceived by Christian theologians, and it was a response to Aristotle's eternal universe, and that is where the argument finds its most basic formation. And then this was developed by Al Ghazali, and he had this a bit more wordy presentation of the KCA than what we're familiar with, saying like every being that has a beginning of its existence has a cause. The universe is a being that has a beginning of its existence, and so on and so forth. So it's like I said, it's much more wordy, and that was Al Ghazali's original presentation. And then years later, in recent very recent history, William Lane Craig worked on it at Edinburgh, Birmingham University in the UK, and gave us with its current formulation that we are familiar with. And so Dr. Craig named it specifically the Kalam, which is the Arabic word for speech, as sort of like a tip of the hat to the Arabic medieval theologians, Islamic theologians who worked on it. And in the introductory module, we looked at deductive and uh, inductive arguments. And so the Kalam cosmological argument, the KCA, is a deductive argument because as it is airtight, you have multiple premises leading to a conclusion. And how do you know this argument is sound? Well, if the premises are true, or as we say, more plausibly true than its negation, and I'm much more relieved that I can use these complex terminologies in this session because of because of all three of you sitting here. We say that if the premises are plausibly true than their negation, then that gives us warrant to take those premises as true. And then if the logic is valid, then the argument is sound. So two conditions: the premises have to be true and the logic must be valid, so that you can connect from multiple premises and lead it to the conclusion. Airtight argument and as such. And uh, if there are if the kalam is of a nature that it has received so much attention to it, such that Quinton Smith, in the Cambridge Companion to Atheism, when it came out in 2007, he notes that the Kalam cosmological argument is the only argument for God that has received so much of attention from philosophical literature and academia, and as such there's no other argument that has generated that much buzz, um, in philosophical academia as the Kalam has done, because it is unique. It's very simple to follow. It's just two premises, and then the conclusion is spot on. It brings in philosophical arguments, it brings in scientific arguments. Premise one is so easy to tackle with. Even Dr. Craig notes that he did not expect people to object to the premise one that much because of how obvious it is. But there were a lot of people who were nitpicking on premise one to say that something can come from nothing as such. Um, and then when Craig went on to show his the analysis of the nature of the cause, pointing that from contemporary philosophical advancement to show that the cause must be a personal cause, and so on and so forth. So the implication of the case is phenomenal. It's simple to tackle with, and which is why it has created a lot of buzz. So that is why I like the Kalam so much, in that you can present it so simply to an audience that is willing to learn. Obviously, any argument, no matter how much you simplify it, the audience has to be willing to work their brain a bit, to understand it. But an audience that is willing to put in the minimum effort will be able to understand the argument. And a person who wants to take it to the next level, they can step by step proceed with parts of the arguments, massive amount of resource out there. And there's an argument that has been so well enhanced and extended, that you can go with Craig's presentation, or if you're like, oh, I think the A theory of time is valid, the time is static, that there is no real past, present, or future. Temporal becoming is not objective, is subjective. All aspects of time is real in sort of like a space-time continuum block. That is how I see time. Then you can go with something like Andrew Locke's presentation of the Kalam, which is adapted to take that also into factor, so that it is even more robust to those objections as well. So that being said, the kalam is of that nature that you can look at it in a simple way. You can progress through it, and then you can get into very sophisticated, highly philosophical, technical engagements of the topic as well if you want to proceed in that manner. Now the premises are very familiar with us. Everything that begins to exist has a cause. The universe began to exist, and then we get to the conclusion that the universe has a cause. Stephen, you can move forward. You can skip on to 2 slides ahead. Um, Now we're going to look at premise one: can something come from nothing? So moving on, we will look at two key distinctions to be noted out. One is understanding the difference between cause and effect, and a simple, an easy way for us to understand it and make it clear to a layperson is by using simple examples like me hammering a nail, the nail moving maybe in a couple of centimeters or millimeters into the wood is the effect, and the cause is me hammering the nail. Yeah, Stephen, you can move to the next slide. So that would be the effect, and this would be the cause. So cause is something that brings the effect into existence. One thing is, yeah. So one thing that we note with cause and effects is that they can be events or states as well. So there will be instances where the cause is an event and the effect is a state. So it would be where now I'm on thinking on my feet about an example. Um, I think an example would be where, yeah, you throw a ball, you throw a plastic ball. Okay, you throw an ice into water, and the cause is me throwing the ice into the water. It's an event, and the ice floats on the water, and that would be the subsequent state. That would be the effect. So the cause is an event, but the effect is a state. Now there are instances where both the cause and the effect are states, and that would be when the ice continues to float on the water. So the effect is ice floating on the water, and that's state. It's not an event; it's a state. What is the cause? The cause is the difference in the density between water and ice, but that is also a state. Now, this distinction becomes very much crucial when we look to the analysis of the nature of the cause of the universe. That's when we come to see that the cause of the universe doesn't seem to be an event, it rather seems to be a state. So, how is it that the state, the cause of the universe, is causing the effect, which is an event, i.e., the beginning of the universe? At what point did the state turn up to cause an event? You have states causing states. Like I said, the density difference between ice and water is a state. It's not an event, it's a state. It is in that form. And that continued state is causing another state, which is ice continuing to float on water. So state is causing state. But when you see that a state is causing an event, that probes the question: why did that state cause an event? What is the nature of that state? Does it have a mind? And you can connect the dots. And it's a very good distinction to follow, and it's very interesting to see when we look at the analysis of the nature of the cause. Then the other distinction that I bring to effect is understanding the different types of causes: material and efficient cause. um, the reason is when we, and I've seen so many people look at the kalam and say, oh, the kalam is telling about creatio ex nihilo, but so nothing of that sort can be seen about the universe and blah 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 and all that sort of stuff. It diverges from the topic, but when we talk about the kalam, telling, as we ourselves learn, or when we are telling to someone else, making the distinction between material and efficient cause is quite useful. Now Aristotle presents 4 causes of information cause and so on and so forth, but I think the other 2 causes are very easy to understand. Now to just refresh our minds, material cause and efficient cause, if you see in a table, the carpenter is the efficient cause, the material cause is the cause. So how does this
Hey, Jacob, you're cutting
is the
out.
wood
Is
out
it
of which
just
the
me?
table is made. So how does this wood
Jacob, hello? Anyone else is there? Hello, is it me?
Yes, but I think it is your problem, Stephen, not Jacob's.
Oh, because for me it's completely stuck now. His video, everything.
Ah, no, no, for us it is not.
It is not. Oh,
Yeah.
weird. Okay, sorry.
Okay, now Jacob is not talking. Hello, Steven?
Yeah, am I back?
Yeah, now you're back.
Okay, okay. Yeah, our Wi-Fi got turned off. Yeah, okay. So I hope I'm gonna stick through. Yeah. So when we say that there is no cause for the universe, we are not saying as in that there is no agent behind the universe coming to existence. That would be equivalent of saying that there is no efficient cause. When we say there is no cause, we are saying that there is no material cause or efficient cause. So with premise one, when we say that if something has to begin to exist, then there must be a cause. We're saying that at the very minimum, you have to have a material cause out of which that thing can come into being. Even if you have no efficient cause, and then it's a whole other question of how does a material cause bring something into existence. Again, a state event causation sort of situation. Why did the material not bring that thing into existence before, and all of that stuff. But stating simply, we are asking we're saying it must have at least a material cause. And then when you look at the beginning of the universe, and we see that the beginning of the universe is the beginning of space and time itself, where Stephen Hawking says, that time itself had a beginning. That probes the question. Okay, so there was not even material cause. There was not even the existence of time, which is way an extreme thing for any scientist to say. So when we point out with premise one that everything that begins to exist has a cause, we're saying that at least there must be a material cause, if not an agent, an efficient cause in action. And that distinction will later down the line help you to clear out some misconception that someone may have, and someone may throw in some sort of creatio ex nihilo and sort of that stuff in there. And that is because of a misunderstanding of premise one. But this clear understanding of what do we mean by cause, material and efficient cause distinction will help clear out confusion out there. And another thing that we have to keep in mind is when we use the term nothing. And some of you may be familiar with Lawrence Cross book and Units from Nothing, and it received a lot of slack because of the fact that Cross was presenting something as nothing. He was taking this physical existent thing and he was presenting as if it was nothing, and therefore, wow, the universe is coming out of existence from nothing, and so on and so forth. You see people pointing towards a quantum vacuum and pointing towards the energy fluctuations in quantum vacuum to force it that things can come into existence from nothing. But quantum vacuum is not nothing. We don't mean nothing to be, just air molecules. No, that is something. And in the next slide, we see one example that Aristotle said. He said that nothing is what rocks dream about. And that is a very good quote, an example to present to a lay audience to immediately get to the point what we mean by nothing. Because we could open a jar and say there's nothing in there, but there is still air. But when we say something of this sort, that immediately gets to the audience what we mean by the term nothing. And Dr. Craig used one example to identify the absurdity of people grappling at the term nothing to make it to mean something, and as such, when he says that nothing stopped Germany's invasion into Poland. And if the person who is hearing it says, "Oh, that's great, Germany was stopped," that obviously sounds absurd, right? The person is saying that nothing stopped Germany's invasion. Yeah, we get it. Nothing stopped Germany's invasion, which means that there was no thing in the way that stopped Germany's invasion. But a lot of people, when they get into the nitty gritties of premise, want to try and somehow disprove one of the premises of the Kalam to make the Kalam break. They get into this extremely weirdly indefensible positions to make nothing seem like it is something, and so on and so forth. So, and this gets very interesting because even Cameron Bird, so not Cameron, but Alex O'Connor, when he interviewed Dr. Craig on his show to talk about the Kalam, even Alex, who recently completed his uh, theology degree from Oxford, a brilliant atheist. I have huge respect for the guy, smart, intelligent. Um, Even for someone like him who has been engaging with the topic for so long, he asked that maybe the universe is the only thing that can come into existence from nothing, right? Maybe all other elements and matters that we see within the universe can only come into being from something, but maybe the universe is the only thing that can come into existence from nothing. Now, the reason he asked that question gave away the fact that he had a huge misunderstanding of the term nothing, and Dr. Craig immediately points that out. When you say that the universe came from nothing, you're saying that there is no thing there that caused the universe to exist. So there is no thing that is existing prior to the universe that has any predisposition whatsoever to bring only the universe into existence. And we'll see this in the next slide where I will clarify it a bit more. that when we look at the three reasons to think that premise one is true, one is saying, that something coming from nothing is absurd, the philosophical absurdity of it. And just it is um, a metaphysical intuition that we understand that something from nothing is absurd, just like the laws of non-contradiction work. It is a metaphysical intuition, just not as something like a simple gut feeling, but it is a metaphysical intuition to say that something coming from nothing is absurd or something cannot come from nothing. But the second point, that if things can come from nothing, if that is a metaphysical law that applies to the universe and to everything in it and to all reality, that if something can come from nothing, then why don't we see things just popping into existence? Why don't we see random things and even specific things like Rabindranath Tagore? He's not as simple as a circle, right? Rabindranath Tagore is a complex person. His identity, his body, all of that. He's a unique individual with consciousness, mind, and so on and so forth. Why don't we see even simple or abstract or even complex things popping into existence from nothing? Why don't we see that? Now, that question has much power when, like I mentioned right before about Alistair Connor's question. When you say that, or maybe the universe is the only thing that could come into being from nothing, you're saying as if that even before anything existed, nothingness had a prior and a property to create only the universe. But nothing means nothing. There is no such thing. It's only things or some things that can have property. There is no thing existing prior to the universe. So, what is the thing that has a property or a predisposition to create the universe? Right? It's such an absurd question to say that nothing had a property to create the universe. There is no thing there to have any property in the first place whatsoever to create only the universe and then refrain from creating or popping things into existence from nothing afterwards. But this distinction, so simple, it's mundane to reiterate over and over. But even this small distinction is missed out by some of the best minds that tackle this question. So, coming to terms, it may take you a couple of, it took me a short while to figure exactly why this distinction was important and why it's a key thing to keep in mind. But having this in mind, making proper sense of it, will enable you to clarify it to others, especially to lay people who may hear this question thrown at them, and they may be like, oh yeah, right, maybe the universe is the only thing that can come from nothing, and they may take it as satisfactory answer. They may not get into the nuances of what it mean by nothing or how absurd the statement is, to say that nothing has a property to create only the universe. There is no thing existing there in the first place. There is no thing as nothing. And then the third argument is that we always see something coming from something. It is verified in our daily experience. It is affirmed in our daily experience. So these are the three arguments that is presented to see that premise one is more true or more probable or more plausibly true than its negation. The absurdity, and then I think the second part is the most pressing question about why we don't see things popping into existence right now. What is the restricting factor that made only the universe come into existence in the first place from nothing? And the third point is that we always see something coming from nothing, which is observational experience. And now moving on, like I said, there is this question that says, maybe this applies to only things within the universe and not to the universe. Here is why pointing out that what premise one is stating is a metaphysical law, not a natural law. So, like I said, this is something that is binding on all of reality, like the law of contradiction. When we talk about when there's discoveries done into stars and galaxies, all of that sort, we assume the law of contradiction to be applicable to all the mathematics and all the equations that are done on all of these distant intergalactic heavenly entities. So premise one is talking about a metaphysical law that binds all of reality, like the law of contradiction, and not of a natural law, which means that if space, time, and matter is part of reality, then premise one applies to all of that reality as well. So this is a quick run through on premise one. There's a lot more things can be said. There are many more objections to premise one, but this sort of gives you a taste of what is at the core of premise one, how other responses to be presented in regards to some of the objections to premise one. Now, moving on, we will be looking at premise two. The universe began to exist. Do we have a past eternal universe? And here we'll be looking at the scientific argument side of it. So, because the idea that the universe and reality in and of itself began to exist was so extreme, the prevalent status quo idea about the universe was that it was eternal. Like I said, Aristotle's eternal universe was aimed at being rebutted by Christian theologians when they presented the original formulation of the Kalam. And for decades, when we see into how different theories for the beginning of the universe was presented, it was always mocked by atheist scientists because Genesis said that the universe began to exist. And until the early 20th century, the prevailing idea in the scientific academia was the universe is eternal. And it was a static model of the universe that was taken to be the explanation of what is the nature of the universe. The universe is static, it is not expanding, it's not contracting, it is as is. Which is why when Albert Einstein presented his general theory of relativity, he had the value for the cosmological constant, which is the dark matter, dark energy in the universe, which is accelerating the expansion of the universe. It is counteracting to gravity's internal pull and speeding up the expansion of the universe. That he initially thought he made a mistake because the understanding was the universe is static. So how can you have something that is speeding up the expansion of the universe? The next slide is this picture of, and this is credit to Dr. Hugh Ross in his book, um, The Creator and the Cosmos. So this is, yeah, in the next slide we see this history of the universe. So you can see that the columns are indicating the age. So to the extreme right, you have the universe or stars and galaxies as they were just 2 billion years after the beginning of the universe. Then you have stars, galaxies that were just 5 billion years old, then 9 billion years old, and then the galaxies that are of the present age as of now, 14 billion years old. So you have the elliptical ones in the top and then the spiral ones below. So you can see that there is an expansion in size of these galaxies as you look forward in time. As you keep looking backward, you see them being smaller and smaller and smaller in size. But present day galaxies, like our Milky Way galaxies, are massive. They are increasing in size and they're expanding at a phenomenal rate. Um, and yeah, this is actually meant for most of our lay audience to sort of see and go wow. I hope it made you go wow as well. Moving on, we want to look at some of the advancement that has happened in in yeah, I think Robert Wilson's name is cut off. Yeah. So moving on, we want to see at some of the advancements that was made in this dialogue of is the universe past eternal as such. So in 1912, Bestow comes and he observes that the velocity of the galaxies are changing relative to our distance, and that was uh, uh, an interesting observation to make at 1912. So this is the beginning of the 20th century. Yeah, the prevalent idea is the universe is static, so on and so forth. Then comes Albert Einstein, and he predicts the universe is expanding with the general theory of relativity. He updates the cosmological constant value, and slowly the idea of an expanding universe is getting into scientific academia. Lemaitre comes and promotes the idea of a Big Bang that Hubble brings forward. That he looks at the redshift velocity of galaxies and he points towards the fact that there is a cosmic expansion happening, looking at what is happening with the galaxies. That the galaxies are going farther and farther based on the redshift light velocities of the galaxy that he observed. Then comes Gamow by the mid 20th century. He points against to the universe expanding, and finally Penzias and Robert Wilson, they detect the cosmic beginnings leftover radiation. And these are all some of the points that maybe you can take note of, sort of see how the trajectory happened towards realizing to the fact that the universe is not exactly past eternal, that there was a slow and steady buildup of, but even some in some sense a rapid buildup of scientific evidence to overturn the existing idea of the fact that the universe was static. So, like I said, this idea that was prevalent before the Big Bang came into picture was steady universe, the static model. And the Big Bang theory gets its name the Big Bang because it was mockingly named by Sir Fred Hoyle. So he was a British astronomer, and it was his prevalent theory that the universe is steady, static, no expansion, no contraction whatsoever. The Big Bang came and said, no, the universe is expanding from a very contractory phase in the recent past. So he mocked the theory and named it the Big Bang. But that name stuck for whatever reason. And soon scientific data and empirical validity started piling up for the Big Bang, making it the running champion. And we're going to look at some of the quotes from the scientists in the next couple of slides. Um, so you have Stephen Hawking saying, it is the discovery of the century, if not of all time. Stephen, 2 slides ahead. Yeah, it's the discovery of the century, if not the all time. And then you have George Smoot, project leader of the COPE satellite, saying, we have found the evidence for the birth of the universe. It's like looking at God, if you're a religious person. Then you have Frederick Berman saying that what they're all talking about is the detection of the cosmic background wave radiation, right? And this is leftover radiation from the Big Bang creation of the universe. And this was predicted by the Big Bang, and this discovery was a huge verifying moment to the fact that the universe did have a beginning, a hot, explosive sort of beginning in recent history. And the COBE satellite, Cosmic Background Radiation Explorer satellite, it picked up on this background radiation that was left after the Big Bang. And Frederick Berman says that this detection of the cosmic radiation has caused scientists to consider creationism a more respectable hypothesis today than at any time in the last 100 years. So, very soon the tide was turning. Like I said, 20th century was a watershed moment, and the idea that the universe had a beginning was gaining pace so far, so quick that the entire media, even when I say the entire media, that this news of detection of the radiation from the Big Bang was so massively publicized in the media. So you have the entire tide shifting towards the idea that the universe had a beginning from a point when entire scientific atheist scientists said, "Oh, the universe is just static. The genesis is just a blunder," and so on and so forth. So all of this tide was changing and it was pointing towards the fact that the universe had a hot big bang beginning. And this cosmic expansion and this initial temperatures were affirmed by continuous discovery. Stephen, you can move ahead a couple of slides. So the reason this discovery of the temperature condition was important is that there was a question of how exactly we had these current elements in their current proportion and quantity that we have right now. And that is where the initial temperature condition of the universe, knowing what temperature was at the Big Bang, um, enabled us to figure out whether those temperatures would give form to the current proportion and formation of the elements, heavy elements, and so on and so forth that we find right now. So, which was one of the main verifying aspect of the Big Bang theory, the understanding of the temperature and then matching up to see whether, given the Big Bang and given those temperature, would we find the current presence of elements. And voila, that is what we figured out. So, in response to the Big Bang, multiple alternate theories were presented, and they all had to account for two things. One, they had to account that the universe was expanding. It was undeniable. Every other theory that you see that came after the Big Bang, except for the steady state, that was the prevalent one. Big Bang came, the field got turned upside down. It threw us a wrench into the sink, um, and what happened immediately was that everyone was presenting theories that said that the universe had is currently expanding, but they were avoiding an absolute beginning. So you had the oscillating model. The universe was contracting before, and then it reversed the clock, and now it's expanding. Soon there will be a contraction, an expansion again, and so on and so forth. And so this will go on for all eternity. You have the chaotic inflationary model, the baby universe model, the Boltzmann brain hypothesis, the expanding multiverse hypothesis, and so many of these stuff. All these theories said the universe is expanding, but there is no absolute beginning. That was the whole point. But all of them faced massive challenges in being verified. Then came in 2000, in early 2010, the Bode-Guth-Villanger theorem, which was a phenomenal theorem in that it showed that any universe whatsoever, that has been expanding over the recent past history and is currently in a cosmic expansion cannot be eternal in the past, must have a space-time boundary. So this was a breakthrough point because this was applicable to models that had even non-cosmic expansion and the models that have cosmic expansion. So this theorem was sort of like a nail in the coffin to this whole dialogue, which is why even when you see in current dialogues, everyone goes after the BGV theorem because of what it implied. And this added more sort of unsurmountable weight to the Big Bang theory, showing that the universe is not past eternal. And William Lane Craig notes that the standard model's prediction of an absolute beginning has persisted through century of progress, theoretical observation in cosmology, and survived an onslaught of alternative theories. And then Alexander Vilenkin, one of the persons in the theorem, he says that he starts off with this interesting point about how people are unreasonable and they require a proof, and which is a very good point to note when a cosmologist is pointing this to atheists. And then he says, with the proof now in place, cosmologists can no longer hide behind the possibility of a past eternal universe. There is no escape. They have to face the problem of a cosmic beginning. So the quote is in the next slide. So this quote by Alexander Willingen was a clear, outright statement that any layperson could make sense of. The Bode-Good-Willingen theorem, and then we'll see another theorem also in the subsequent slides, um, close the door to any sort of ever expanding past eternal universe idea that people were trying to promote. Even I think even right now the more prevalent idea that is being pushed forward, um, I think is the chaotic inflationary model. I may be wrong, but the challenge of the BGB theorem still amounts to all of it. The second argument, so the two arguments for the fact that the universe had a beginning. The one was the expansion of the universe and the Big Bang theory and what it presented to us, telling about the beginning of the universe. The second is the second law of thermodynamics. Right? The second law of thermodynamics basically says that when you have heat transferred from, and this was originally formulated by Lord Kelvin, he says that in the cyclical function, when heat is transferred from one body to another, you will have heat being lost. The temperature of the first body is going to be higher than the temperature of the second body because there is heat going to be lost in the process. Subsequently, that the second body is going to have a lower heat, a lower temperature, and which means that like a clock, the the universe is slowly winding down. Now, given that the universe is a closed system, and given that the atheists, naturalists, materialists take the universe to be a closed system, there is not going to be any energy that is going to be fed from the outside. Which means if the universe starts with 1,000 joule of energy in the beginning, that's all it has. No pumping up, no stacking up, nothing of that sort. No refreshments, no refilling, nothing. And slowly the energy source is running out, which is what the second law of thermodynamics is, which is why the second law of thermodynamics presents this very important and quite really hard to rebut argument for um, the beginning of the universe, the fact that the universe is not past eternal, because the universe is slowly running out of energy. And so what we see then is the next slide we see that the universe has limited energy, but these eternal models tell that the universe has unlimited time, right? The universe has been here forever. There is no immediate beginning of the universe, no absolute beginning. So we have limited energy, but unlimited time. So which means that if you take in a fact that the infinity is not really a trillion years old, like infinity is way more than a trillion. It is way more than 100 trillion. Your limited energy will have already run out by now, because by now we will have traversed literal infinity to be at this moment in time. So your limited energy is going to run out. So then you must have unlimited energy and have limited or unlimited time. But if you have limited energy, then the only thing that follows is that you have limited time, which is why we still haven't run out of energy. We are still here. And so this second law of thermodynamics is a very good, a very strong argument to point towards the fact that the universe is not eternal in the past, a finite beginning with finite amount of energy. And this the second law of thermodynamics is sort of like a closed science. There is no breakthroughs that has happened. It is understood, no challenge whatsoever. So it holds. The fact that the universe has limited energy and that entropy is functioning, again, closed science. The only thing is coming to term with the fact that therefore the universe has limited time. Which is why even if you see that all of the objections to the Kalam has to do with objecting to the Big Bang. So even with Sean Carroll's debate with Dr. Craig and every other Kalam debate, that even that if I recall that Alex O'Connor presented also his talk on the Kalam, they would all go primarily after different models of the universe, saying that the universe did not begin to exist, and so on and so forth. Because the thermodynamics part is quite hard to tackle head on. And Paul Davies, he notes in this quote that you can't say that the universe has been always here because it's a paradox. The suns and stars cannot keep burning; they will run out of fuel and die. And so then he notes the universe can't have existed forever. We know, therefore, we know there must have been an absolute beginning a finite time ago. So this sort of gives you the idea about where contemporary scientific question is standing on this question. And so Paul Davies of Arizona State University is one of the most respected cosmologists, physicists of our time, and this sort of and he's an agnostic, and this sort of gives sheds massive light into where academic evidence and scientific evidence is pointing towards to the two arguments for a beginning of the universe. Now, the other advancement that came is with the Hawking-Penrose singularity theorem, and this was enhancement on the general theory of relativity, and they adapted it to apply to both space and time. And this theorem, the singularity theorem, also shows that there is a singular boundary in the past for the universe. Not that, and again, outline out. removing out the fact that the universe could have an eternity behind in its past. That there is a singular boundary applying to both space and time in the past, which then leads to this stark claim by Stephen Hawking, which says that time itself must have a beginning. So this was the outworking of his work and what was even eventually presented in the Hawking-Penrose theorem to say that time itself must have a beginning. And he says in A Brief History of Time, this very interesting quote, he says that many people do not like the idea that time has a beginning, probably because it smacks of divine intervention. This is what we're getting into crux to what is happening in the minds of cosmologists and astronomers who are denying the beginning of the universe. Not exactly because there isn't ample scientific evidence, but because they want to grapple at things like the Planck era, 10 to the power negative 43 seconds after the universe popped, 43 seconds after the universe began to exist, to look at this very speculative, complicated, highly speculative area to try and somehow fit in a version of an expanding, ever expanding, never contracting, eternal universe in there. The reason is because when you say things like time itself had a beginning, that is way more of an extreme claim to say that than saying something like space or matter had a beginning. Right? That is thing that even layperson may get to wrap their head around. But to say stuff like time itself had a beginning is way complex. And Stephen Hawking himself, if to the best of my knowledge, does not take that the universe has a finite beginning. Which is why Dr. Hugh Ross points out that Stephen Hawking comes to this conclusion, and then he throws in stuff like imaginary numbers, like a root of one, right? He throws in these imaginary numbers to somehow avoid and deviate from an absolute beginning of the universe. And this is an open admission from Stephen Hawking that it smacks of divine intervention. When we look at the fine-tuning argument, we will see quote from Sir Fred Hoyle when he says that it is evident that someone has monkeyed with with the physics and chemistry of the universe. To say stuff like someone has monkeyed with physics and chemistry of the universe is an outright acknowledgement of the fact that there is much more things happening behind the scene than just pure or random chance or disorder. And this comes us to the recap of what we've seen so far. We saw premise one, everything that B says is a cause, and we saw that something cannot come from nothing, which is what premise one is talking about. The three arguments for that, the absurdity of it, then the question if something can come from nothing, then why doesn't this happen always? Then we looked at the third argument, which is that we see premise one affirmed in our daily observations time and again. We looked at premise two that the universe began to exist, and we looked at the two arguments for the case of the beginning of the universe, which is causing the expansion, and the second law of thermodynamics. Again, noting that the second law of thermodynamics hold much sway and is really hard to rebut, not much space for speculation, as people may do with the cosmic expansion of the Big Bang theory and as such. So that brings us to the conclusion of this session on the Kalam cosmological argument. And we're still, yeah, we're on schedule. So I hope I was that was understandable for all of you there. I'm confident that you're all able to catch up with what I presented because I know how well you've been engaging with these topics. Um, Before we get to the end of the session, is there any questions, any clarification that you want, any interesting notes that you may have to add, anything of that sort?
Jacob, if you can cover this portion, that how the first law of thermodynamics does not conflict with the case. That would be great.
Yeah, can you repeat how the
First law of
thermodynamics
does not
how the first
conflict with the KCA.
Heard
you know what
he said. No, Jagaja, your audio is cutting off a little bit. Should I repeat? I'll repeat the question. So Jacob Cha was asking, how does the first law of thermodynamics not conflict with the KCA?
Okay, yeah. I haven't seen anyone. Oh, I have never seen anyone bring up the first law of thermodynamics with regard to the KCA. Jacob, can you add on to? Have you seen anyone bring up that?
Yeah. We have people in the marketplace who brings that up. So are you able to come in?
Yeah, I can hear you.
So what I'm trying to say is, in the marketplace, there are people who bring it up because the first law of thermodynamics says, right, that the mass it cannot be created. The mass and the cannot be created, not destroyed, but it only changes from one form to another, right? So because we are saying that Kalam cosmological argument that everything has everything that begins to exist has a cause. So they try to say that the mass need not have a beginning. So that's the point.
Yeah. Okay. I had forgotten what the first law of thermodynamics was. Yeah. So okay. Now I'm wondering why is it even that an objection that is being brought up in the first place? Because like you've seen with all the evidence that is stacking up for the Big Bang theory and evidence for the finite beginning of the universe, like we saw with admissions, like the time itself had a beginning. The overwhelming scientific consensus is that space, time, and matter had a beginning, right? Which means that matter, mass, energy, all of that had an absolute beginning in the finite past. Now, when they get into the nuances of eternal universe and as such, then everything goes for a toss because then all of that has been pre-existent and so on and so forth. But if they are following with, if Big Bang theory is true, then that means that energy, mass, and as such, where they all had an absolute beginning. But I think the first law of thermodynamics may be talking about what can happen right now within the universe. As in, you have all this energy and stuff, it just keeps on changing form. You can't create anything new within the universe, right? Again, we're talking about natural laws, we're not talking about metaphysical laws, so we can have the distinction of before the universe began and within the universe. So I think we'll have to see at what exactly the first law of thermodynamics is saying per se, when it says that these can't be created. And then it's a challenge for Big Bang theory first and foremost to say, can matter begin? Could matter have ever begun to exist? The other thing is when it says that, when the first law of thermodynamics says that matter and energy cannot be destroyed. Again, we're just talking about what can happen within the universe. But we know what is going to be the eschatology for our current universe. We're running out of energy. We're going from low to high equilibrium. We're moving towards entropy. We're losing energy. So the universe is going to have a heat death. So much so that there is one of the speculations is that one of the eschatological scenario is that the black holes are going to coalesce into one black hole, so that everything is just going to be sucked in and the new universe will not re-emerge. So how does that apply for the first law of thermodynamics? Um, is matter going to be transformed into something else in the black holes and so on and so forth? So those are all, I think, questions that is beyond our, and definitely beyond my pay grade. Um, but I think, yeah, I don't think this is much specifically an objection to the Kalam per se. Yes, it is an objection for uh, for the Big Bang theory when it says that mass and energy cannot be created. But then again, like I said, it may have to do with uh, it may have to do with what is meant what is meant by the first law of thermodynamics, as in that you cannot create new mass or energy within the universe. You are only working with what is currently in the universe. I think
I
that
would
may be what the
think you're
first law
right
says. Yeah.
also. I would think you're right in that case, right? Because even the second law of thermodynamics acts within the constraints of what already exists, right? It
Yeah.
says that what we are quickly running out of usable energy. So that is a constraint within the universe that points to the fact that there was a beginning at which there was complete no entropy and it was completely usable energy, right? So in the
Yeah.
same way, within the constraints of the in the of the natural law, the first law of thermodynamics says that the energy cannot be created nor destroyed, but rather it can only be transferred from one kind of energy to another. For example, I think from what I remember, it is potential energy turns into kinetic energy. Like if you were
Yeah.
to throw a ball, your hand motion from where you have your whatever, when you wind up your hand to throw the ball up, that's the potential energy that transforms into kinetic. But again, all of these are constraints within the universe that already exists, and because of that fact, you can use the first law of thermodynamics to equally kind of argue for both sides, I would imagine. uh,
Hmm.
because um, even if it had to be created, the potential energy could be, I would say, God. I don't know whether that's an easy way to kind of explain it, because God in that sense would be metaphysical rather than within the natural constraints, right?
Yeah, yeah, that would be a stretch for us to.
But again, the eternal universe concept would directly contradict the second law. So
Yeah, definitely.
So
Um,
basically one logical argument that I found was, and I was speaking to Ashish, right? Our guy from Hyderabad. So Ashish was telling that the best explanation to that is all laws of physics is subject to the symmetry of space and time within the universe. So it takes assumption of space and time within the universe. So that's how it.
what? I didn't hear you. What? What was the logical? And I didn't get what? Did you
Are
hear?
you
okay,
able
Jacob,
to, are you able
can
to
you
hear
repeat
me?
once more?
I'm driving. That's the reason. So are you able to hear me?
Yeah, yeah,
Yes,
yeah.
yes, yes.
So
No.
so what Ashish said was all laws of physics are applicable within the symmetry of space and time within the universe. And Kalam
Hmm.
cosmological argument comes before that.
Yeah,
Right?
that's right.
So
Yeah.
the Kalam cosmological argument talks about the beginning of the universe, right? So
Hmm.
I think
so
that's what even Jacob was driving at as well, right? Because these are within the constraints of the existing universe, not predating it into
Yeah.
physics, right?
So I was just looking at the definition of the first law. It says the first law of thermodynamics tells us the amount of energy in the universe is constant and can neither be destroyed or created. So again,
See,
we're
there
talking
we go.
about what,
Yeah.
yeah, what is going to happen with the energy that is already there within the universe. Yeah, so I think that sort of clears it up. But Jacob, I found Dr. Craig responding to the first law of thermodynamics and a Sean Carroll video on did the Big Bang break the laws of thermodynamics. So I'll drop that in the group. Um, so that's interesting because I've even with Dr. Craig's that video, 10 worst objections to the Kalam. Even that also he doesn't mention this
First
first law
law.
of thermodynamics.
Is
Even
it
though all that
bad?
I've learned, yeah, I think it's because maybe I think maybe it comes from a very brute misunderstanding of the law. That could be it. But anyway, I will look at these other materials that I found and
What
I will
about the
update in the
third law also? Does the third law play any role? Is there a third law of thermodynamics? Is there? Oh, there is.
yes,
There is a third. There's even a zeroth law of thermodynamics.
what is the third law?
Third law, the entropy of a system approaches a constant value when its temperature approaches absolute zero. The entropy. So this is regarding properties of closed systems. So
Yeah.
essentially, the closed system is the universe, I would assume. The
but
entropy of a system approaches a constant value when its temperature approaches absolute zero.
yeah, but
Hmm.
that doesn't contradict the
That
case.
doesn't have anything to do with that. Would,
I
um,
don't think it has anything to do with.
entropy of a okay, zero, zero. That doesn't prove either case, I would say.
Yeah. Anyway, yeah, I'll drop these other results that I found about Big Bang and first law. Um,
This right. This it's very interesting to see that there's even a zeroth law of thermodynamics. Do you know why exactly we have these kinds of like obviously the first law of thermodynamics must have come first before the zeroth law, because then we wouldn't have a zeroth law, right? That would have been thought of afterwards, which is why they put zero. So there
I
must
think
be an order
zero.
that exists. The the
Yeah, the
zero.
zeroth law. It says that if two thermodynamic systems are each in thermal equilibrium with the third system, then they are in thermal equilibrium with each other. So it's sort of like Euclid's theorem as such, a very like an undergirding assumption sort of a thing. It's giving that impression.
Mm.
Thermal equilibrium between systems is a transitive relation. So like if A is equal to B and B is equal to C, then their A is equal to C.
Right. Is that what it is? Okay.
Yeah. So I think it's sort of like the zeroth law is sort of the sensible assumption to be made for you to
For
talk
you,
about multiple equilibrium situations, sort of a
right.
thing. So maybe that's why the zeroth law.
Makes sense. Very interesting. It just
Yeah.
makes me wonder whether the first, second, and the third follows each other just like the zeroth law. But I think the zeroth law is just meant to be the undergird of the first, second, and third, and first, second, and third can be referred in any order.
Could be, yeah. If the first one is that mass can either be created or destroyed, second is um no, it doesn't. Okay, it doesn't look to me as one is following the other.
Yeah,
As in, it doesn't
it
look
doesn't
that way, right?
look like that. So it seems more like, what is it like? Each they could be taken in any order, but the zeroth law is what kind of is the base for all three.
Yeah.
No, just like the three laws of what is the Newton, whatever that is. I forgot.
Yeah, Newton's three laws, sort of. Yeah, I like that. Yeah. So, yeah. Any other thoughts or questions? We're already 9 o'clock, so I think Shubhra had to leave.
Yeah.
So before we wrap up, any other pointers or anything? So then what I'm thinking about in the next session is to look at the philosophical arguments for the beginning of the universe. I don't know if the audience group is going to be similar to what we had right now, then I could get into some of the extremities, but I don't know. I don't know what the turnout is going to be next week. So I'll
Right.
prepare for a layman thing, and I will keep sophisticated one ready to get into, because we'll be talking about things like actual infinity, absolute infinity, potential infinity, the possibility of actual infinity, um, the logical possibility of actual infinity, the real world possibility of actual infinity, an infinite set of things. It's a very complex thing to wrap your head around. At least just for me. So let's see what the turn is going to be next week. But this was nice. I was able to talk with that technical flow.
The cosmology is here. You have to stop recording.
Yeah, Cha?
To stop the call.
You have to stop recording.
Oh yeah, I'll do that.
All right. Oh wait, I'll stop it. I think I'm the one.
Yeah.